Okay. Hello. Okay, sounds good. Can you hear the music? Looks a bit bad, no? I had put it at, oh shit. Okay, anyways, and the YouTube stream looks good as well. Can we hear it? Alright. Gotta post it on my Discord. Hello. I don't know how to read your name, Katze. Alright. Let's close this. And we're ready. Okay, hello guys. Welcome to the stream. Today we'll be learning some Vulkan. Yeah, so I'm not sure what awaits us. I should probably move these two tabs to the right. Merge this. Okay. It's gonna be pretty interesting. I've done a ton of OpenGL, more than what I would have liked, so we'll see how Vulkan works. Yeah, I'll just keep most of this. But I should remove glue, no? Yeah, I should remove glue. I once tried and it was already pretty complicated while I hadn't drawn anything yet. Oh, we'll see then. I mean, I feel like it shouldn't be that hard, but maybe it is. I should probably strip out like most stuff to not cheat, so this, render, I'll leave most of it. Shader loading, I can leave it for reference, and UI I can leave it too. Shaders, I mean, I guess I can keep nothing, just a folder. Scenes, what does it have? Yeah, out. And this is going out as well. Sync create, we don't need it. We just need to draw a triangle, which is to do. I know it takes 1K lines of code. First triangle, yeah. But I was curious, what if I learn just the basics of OpenGL and then can I start with Vulkan? Well, I don't know. I mean, I haven't learned Vulkan yet, so I don't know how complicated it is. So I can't advise you there, but Vulkan is decently easy to use. In my experience, it was. So that's a good starting point. What will you build? I'm not sure. I'll see what I can manage. First, I want to integrate like everything that I had before, all these scenes. I was thinking of a Minecraft clone. Well, I was thinking of this. I was thinking of doing a Minecraft clone in OpenGL and a Minecraft clone on Vulkan. Have around the same code and benchmark a bit of performance, how easy it is to do each of them, and yeah, I think I will get a good understanding after that. For the 1 second, I thought you were using Raylive. Yeah, it's I like how it's abstracted, how Raylive is abstracted, so I just left it like this. Hello, hello. I'm gonna just go with OpenGL. That is it. Yeah. No need to overcomplicate it. Okay. Still didn't detect that I don't have this. Geo viewport. Check compile errors. Yeah, I don't know. I guess I would just remove this. I'll remake it anyways. Okay. Well, let's go. I'll be back in a second. Okay. So I can see you're doing paint again for yourself. Yeah. Are you going to use library or only or some initializer? No, just plain Vulkan. I don't think there are any initializers for C, though I'm not sure. I think there was BK Bootstrap or something. But anyways, I saw that it was just 500 lines of code to initialize, so I'm okay with that. I like it more. Bulk? Is that the name of the library? I'm not sure. Okay, well, this tutorial will teach you about the basics of using the Vulkan Graphics API and Compute API. Vulkan is a new API by the Kronos Group, known for OpenGL, that provides much better abstraction of modern graphics cards. This new interface allows you to better describe what your application intends to do, which can lead to better performance and less surprising driver behavior compared to existing APIs like OpenGL and Direct3D. The ideas behind Vulkan are similar to those of Direct3D 12 and Meadow, but Vulkan has the advantage of being fully cross-platform and allows you to develop for Windows, Linux, and Android at the same time. However, the price you pay for these benefits is that you have to worry for significantly more reverse API. Every detail related to the graphics API needs to be set up from scratch by the application, including initial frame buffer creation, memory management for objects like buffers, and texture images. The graphics drivers will do a lot less hand-holding, which means that you will have to do a lot more work in your application to ensure correct behavior. More like 1,000 lines for initialization. Damn. The takeaway message here is that Vulkan is not for everyone. It is targeted at programmers who are enthusiastic about high-performance computer graphics and are willing to put some work in. If you're more interested in game development rather than computer graphics, then you may stick to blah blah blah. With that out of the way, let's cover some prerequisites for the following tutorial. A graphics card and a driver compatible with Vulkan. Minus experience with C++. I do have experience, but I'm not going to use C++. Some existing experience with 3D computer graphics. You're good. This tutorial will not assume knowledge of OpenGL or direct 3D concepts, but it does require you to know the basics of 3D computer graphics. I will not explain the math behind perspective projection, for example. See this resource, okay. Computer graphics resources are Vulkan being used in a real engine in the open source Quake and Doom 3. Cool. By the way, for future, render passes are deprecated as of Vulkan 1.4. Dynamic rendering is now main route. It's supported since Vulkan 1.1, I think. Okay. Keep it in mind. You can use C instead of C++ if you want, but you will have to use a different linear algebra library and you'll be on your own in terms of code structuring. Yeah. Alright, organized logic and resource lifetimes. There is also an alternative version of this tutorial available for Rust developers. Oh, no. Using other programming languages and to get some experience with the API, we'll be using the original C API to work with Vulkan. If you're using C++, you may... if you prefer to read this book as an ebook, okay. We'll start with an overview of how Vulkan works and the work we'll have to do to get the first triangle on the screen. The purpose of all the smaller steps will make more sense after you've understood their basic role in the whole picture. Next, we'll set up development environment with the Vulkan SDK, GLM library for linear algebra, and GLFW for window creation. This tutorial will cover how to set these up on window. Okay. Well, that's a lot of boilerplate for the for the about. This chapter will start off with an introduction of Vulkan and problems it addresses. After that, we're going to look at the ingredients that are required for the first triangle. This will give you a big picture to place each of the subsequent chapters in. We'll conclude by covering the structure of Vulkan API and the general use patterns. Hello, PyTrader detective. Just like the previous graphics APIs, Vulkan is designed as a cross-platform abstraction over GPUs. The problem with most of these APIs is that the era in which they were designed featured graphics hardware that was mostly limited to configurable fixed functionality. Programmers had to provide the vertex data in a standard format and were at the mercy of the GPU manufacturers with regards to lighting and shading options. Terrible. As graphics card architectures matured, they started offering more and more programmable functionality. All this new functionality had to be integrated with the existing API somehow. This resulted in less than ideal abstractions and a lot of guesswork on the graphics driver's side to map the programmer's intent to the modern graphics architectures. That's why there are so many driver updates for improving the performance in games. sometimes by significant margins. Because of the complexity of these drivers, application developers also need to deal with inconsistency between vendors, like syntax that is accepted for shaders. Yeah, I've seen this. Aside from these new features, the past decade also saw an influx of mobile devices with powerful graphics hardware. These mobile GPUs have different architectures based on their energy and space requirements. One such example is tiled rendering, which would benefit from improved performance by offering the programmer more control over this functionality. Another limitation originating from the age of these APIs is limited multi-threading support, which can result in a bottleneck on the CPU side. Vulkan solves these problems by being designed from scratch for modern graphics architectures. It reduces driver overhead by allowing programmers to clearly specify their intent using a more verbose API, and allows multiple threads to create and submit commands in parallel. It reduces inconsistencies in shader compilation by switching to a standardized bytecode. This was SpearB. Lastly, it acknowledges the general-purpose processing capabilities of modern graphics by unifying their graphics and compute functionality in a single API. What it takes to draw a triangle. A Vulkan application starts by setting up the Vulkan API through BK instance. An instance is created by describing your application and any API extension you'll be using. After creating this instance, you can query for Vulkan supported hardware and select one or more physical devices to use for operations. You can query for properties like VRAM, device capabilities to select desired devices, for example, to prefer using dedicated graphics cards. Makes sense? First time catching the live stream here, you implemented C23 standard? Yeah. Well, I don't know what you mean by implemented. I'm just using C23 for the project. To be a bit more modern. UI. Logical device and queue families. After selecting the right hardware device to use, you need to create a BK device, logical device, where you describe more specifically with BK physical device features you'll be using, like multi-viewport rendering and 64-bit floats. You also need to specify which queue families you would like to use. Most operations performed with Vulkan, like draw commands and memory operations, are asynchronously executed by submitting them to a BK queue. Okay. A bit modern. Yeah, I mean, it's not like much changes. Are allocated from queue families, where each queue family supports a specific set of operations in its queue. For example, there could be separate queue families for graphics, compute, and memory transfer operations. The availability of queue families could also be used as a distinguishing factor in physical device selection. It is possible for a device with Vulkan support to not offer any graphics functionality. However, all graphics cards with Vulkan support today will generally support all queue operations that we are interested in. In off-screen rendering, you'll need to create a window to present rendered images to. Windows can be created with the native platform APIs or libraries like GLFW and SDL. We'll be using SDL. Yeah, we need two more components to actually render to a window surface and a swap chain. Note the KHR postfix, okay, which means that these objects are part of a Vulkan extension. The Vulkan API itself is completely platform agnostic, which is why we need to use the standardized WSI, Window System Interface extension, to interact with the window manager. Okay. The surface is a cross-platform abstraction over Windows to render to, and is generally instantiated by providing a reference to the native window handle. For example, on Windows. Luckily, the GLF library has a built-in function to deal with the platform specific details of this. Okay, good. I've been modernizing my C codebase to the most recent C23 as well, along with implementation modern tools like static analyzers and sanitizers. No, non-KHR, yeah. I've played with some OpenGL extensions too. By the way, what static analyzer have you used? Because I couldn't find any good one for C. Or for my use case at least. The subchain is a collection of render targets. Its basic purpose is to ensure that the image that we are currently rendering to is different from the one that is currently on the screen. It is important to make sure that only complete images are shown. Every time we want to draw a frame, we have to ask the subchain to provide us with an image to render to. When we have finished drawing a frame, the image is returned to the subchain for it to be presented to the screen at some point. The number of render targets and conditions for presented finished images to the screen depends on the present mode. Common present modes are double buffering, vsync, and triple buffering. We'll look into this in the subchain creation chapter, okay? That's interesting. To render directly to a display without interacting with any window manager through KHR display and the KHR display swapchain extensions. This allows you to create a surface that represents the entire screen and could be used to implement your own window manager, for example, which we're not going to do. Never done any actual graphics programming though, only played a bit with C and Relu. Well, that's some graphics programming. Render passes in Vulkan. To draw an image acquired from the subchain, we need to wrap it in BK image view and BK frame buffer. An image view references a specific part of the image to be used, and a frame buffer references an image views that are to be used for color, depth, and stencil targets. Because there could be many different images in the subchain, we'll preemptively create an image view and frame buffer for each of them and select the right one to draw the time. Interesting. Next project is Lebowski WM. Yeah, I don't know. Render passes in Vulkan describe the type of image that are used during rendering operations, how they will be used, and how their content should be treated. In our initial triangle render application, we'll tell Vulkan that we will use a single image as color target and that we want it to be cleared to a solid color right before the drawing operation. Whereas a render pass only describes the type of image, actually binds specific images to slots. Graphics pipeline, I've seen this part. The graphics pipeline in Vulkan is set up by using BK pipeline object. It describes the configurable state of the graphics card, like the viewport size, depth buffer operations, and programmable state using BK shader module objects. The shader module objects are created from the shader bytecode. Oh, right, so it's preview. The driver also needs to know which render targets will be used in the pipeline, which we specified by referencing the render pass. Need some water. Compared to existing APIs, that almost all configuration of the graphics pipeline needs to be set in advance. That means if you want to switch to a different shader or slightly change your vertex layout, then you need to entirely recreate the graphics pipeline. which is what happens under the hood when you do GL use program, I guess. Like it caches it, and if there's already a pipeline, then it uses that one. Create many pipeline objects in advance for all the different combinations you need for your rendering operations. Only some basic configurations like viewport size and clear column can be changed dynamically. All of this state also needs to be described explicitly. There is no default color blend state, for example. Okay. Equivalent of ahead of time compilation versus just-in-time compilation. There are more optimization opportunities for the driver, and runtime performance is more predictable, because large state changes like switching to a different graphics pipeline are made very explicit. By the way, do you have a window manager, right? Yeah, I have RenderDoc installed. I have used it. I've dealt with my fair share of black screens. As mentioned earlier, many of the operations in Vulkan that we want to execute, like drawing operations, need to be submitted to a queue. These operations first need to be recorded into a BK comment buffer before they can be submitted. These comment buffers are allocated from a BK comment pool that is associated with a specific queue family. To draw a simple triangle, we need to record the comment buffer with the following operations: begin render pass, bind the graphics pipeline. Like you need to create it and then bind it. Draw 3 vertices and the render pass. Because the image in the frame buffer depends on which specific image the subchain will give us, we need to record a command buffer for each possible image and select the right one at draw time. The alternative would be to record the command buffer again every frame, which is not as efficient. Command pools are something like array storage for command buffers. Okay. And in the main loop, now that the drawing commands have been wrapped into a command buffer, the main loop is quite straightforward. We first acquire an image from the subchain with this. We can then select the appropriate command buffer for that image and execute it with bkqsubmit. Finally, we return the image to the subchain for representation to the screen with bkq%khr. Operations that are submitted to the queue are executed asynchronously. Therefore, we have to use synchronization objects like semaphores to ensure a correct order of execution. Execution of the draw command buffer must be set up to wait on image acquisition to finish. Otherwise, it may occur that we start rendering to an image that is still being read for presentations on the screen. The bkq% call in turn needs to wait for rendering to be finished, for which we'll use a second semaphore that is signaled after rendering completes. This whirlwind tour should give you a basic understanding of the work ahead for drawing the first triangle. A real-world program contains more steps like allocating vertex buffers, creating uniform buffers, and uploading texture images that will be covered in subsequent chapters. But we'll start simple because Vulkan has enough of a steep learning curve as it is. Note that we'll cheat a bit by initially embedding the vertex coordinates in the vertex shader. Oh, okay. That's because managing vertex buffers requires some familiarity with command buffers first. So in short, to draw a triangle, we'll first need to BK instance, select the supported graphics card, create a BK device and a BK cube for drawing and presentation, create a window surface and subchain, create the subchain images with BK image view, create a render pass that specifies the render targets and usage, create frame buffers for the render pass, set up the graphics pipeline, allocate and record the command buffer with the draw commands for every possible subchain image, draw frames by acquiring images, submitted the right draw command and returning the images back to the subchain. That's a lot of steps, but the purpose of each individual step will be made very simple and clear in the upcoming chapters. If you're confused about the relation of a single step compared to the whole program, you should refer back to this chapter. I get it. I mean, it's it doesn't seem that hard, honestly. We'll conclude with a short overview of how Vulkan is structured at a lower level. Okay. Using a modern API like Vulkan now is like using Nintendo 64 PlayStation to render. Super hard for a simple triangle. I've never seen the PlayStation 2. Oh, never mind. I did see it. Just a long and very explicit, yeah. If you don't do subpasses, it shouldn't be as long. Dynamic rendering is part of the course since. Yeah, Toza said it was since 1.1. I would like to learn both ways anyways. All of the Vulkan function enumerations and structs are defined in the Vulkan.h header, which is included in the Vulkan SDK developed by LunarG. We'll look into installing this SDK in the next chapter. Functions have a lowercase bk prefix. Types like enumerations and struct have a bk prefix with a capital and a bk underscore prefix for enumeration values. The API heavily uses structs to provide parameter to functions. For example, object creation generally follows this pattern. Create the object, add the values, create the object. So very C-like. Many structures in Vulkan require you to explicitly specify the type of structure in the S-type member. The pNext member can point to an extension structure and will always be null pointer in this tutorial. Functions that create or destroy an object will have a bk. Oh, I clicked on it. We'll have a bk allocation callback. Okay. Allows you to use a custom allocator for driver memory, which will also be left null pointer in this tutorial. Almost all functions return a bk result that is either a bk success or an error code. This specification describes which error codes each function can return and what they mean. Validation layers, as mentioned earlier, Vulkan is designed for high performance and low driver overhead. Therefore, it will include very limited error checking and debugging capabilities by default. The driver will often crash instead of returning an error code if you do something wrong, or worse, it will appear to work in your graphics card and completely fail on others. Yeah, that can be bad. To enable extensive checks through a feature known as validation layers. Validation layers are pieces of code that can be inserted between the API and graphics driver to do things like running extra checks on function parameters and tracking memory management problems. The nice thing is that you can enable them during development and then completely disable them when releasing your application for zero overhead time. Yeah, that's what I thought they did. Anyone can write their own validation layers, but the Vulkan SDK by LunarG provides a standard set of validation layers that we'll be using in this tutorial. You also need to register a callback function to receive debug messages from the layers. Because Vulkan is so explicit about every operation and the validation layers are so extensive, it can actually be a lot easier to find out why your screen is black compared to OpenGL and Direct3D. That's good. There's only one more step before we'll start writing code, and it is to set up the development environment. Okay. Oh, 1.1 was an extension and 1.3 was native. I just checked. Oh, okay. And when was 1.0 launched, like 2016? So 1.3. Shouldn't have been that long after. So if you're developing on Windows, then I'll assume that you're using Visual Studio to compile your code. I'm not, but it includes the headers, standard validation layers. The loader looks up the functions in the driver at runtime, similarly to glue for OpenGL, if you're familiar with that, yes. Using the buttons at the bottom of the page, you don't have to create an account, but it will give you access to some additional documentation that may be useful to you. It's an installer? What? That's my... That means that it's installing, and that means that it installed. In installation, pay attention to the install location. The first thing we'll do is verify that your graphics card and driver properly support Vulkan. Go to the directory where you installed and open, and you'll see the following. Okay, so it doesn't say I have to click on any of this. GLM headers. Yep, 2016. Most mobile should support 1.3 now, even, and desktops even earlier, yeah. We got a follower. I don't know from where though. Plurs27, thanks for following. I think it's from Twitch. Feels okay, man. Hello. Okay, just skip that. Accept the license. Run the Vulkan configurator. Okay. Never mind. Well, it's doxing me. It was bin and what? GLS. What? No, never mind. BK cube. BK cube. Okay. It's not using delta time, so I think it's spinning super fast because I have high FPS. Nice. Didn't receive an error. There's another program in this directory that will be useful for development. The GLSL lang validator and GLSC.exe will be used to compile shaders from the human readable GLSL to bytecode. I thought we used HSL. Wait, how is it called? Yeah, HSL. Well, I guess I should move those, or I'll just copy the path for now. I can remove that. It should go somewhere on here. Thanks for IP, yeah. Add to path? Sure. Where is path? I'm guessing I have to add bin. Yeah, probably. What? I have to remove something? Love to be, fuck you. What else? Western, no. Okay, that. Oh god. What else do I have? Java. But how, what do you mean? Like it's small? Cancel? Edit? Used mainly by big game companies, DXC can be used to compile it to SpearV, but not all features may be there. Since it's bytecode, it can be... Yeah, I wanted to use slang to try it out. Racer Chroma. Oh, it's at the top anyways. Okay, well. Oh god. What is going on? Okay, it works anyways, whatever. Like if I use this... maybe I need to restart the console. Well, we'll see. Maybe I have to restart my new one. Nope. And here? Yeah. Okay, so it doesn't work on here. I think Vulkan SDK provides slang compilator, but I may be mistaken. No, I think you have to download it from source. I'm guessing. Yeah. Feels like so. Okay. GLFW bytecode. We'll cover this in depth in the shader module chapter. Okay, the bin directory also contains the binaries of the Vulkan loader and the validation layers. Well, the lib directory contains the libraries. I should probably add that to path as well. My hands are so cold. Lib. Why is there CMake here? Don't give me CMake. It's gonna give that error again. Did it work? What the fuck? Okay, I'm assuming it got in there. I'm gonna try again. Also, it's not removing stuff that I remove. I've never seen that error before. Oh, okay. There we go. Check if you have slang. See, yeah, I'll check it. Oh yeah, it is here. If you use CMake, it should be able to find Vulkan SDK by itself. I've seen, yeah, but I have my own build system, so we don't need CMake. Yeah, and then there's include directory that contains the Vulkan headers. Feel free to explore the other files, but we won't need them for this tutorial. Oh my god. Wait, then maybe it's not. I mean, I should probably just add this, and then I can just go bin. Where's the last one I added here? Before Vulkan by itself, yes. GLFW. There's another library available for this purpose, like SDL, but the advantage of GLFW is that it abstracts away some of the other platform-specific things in Vulkan besides just window creation. Yeah. GLM, we already have CGLM, setting up Visual Studio. Okay. And this is the initial code. Vulkan for SDL3, or the other way around. Or never mind, yeah, that's fine. I wanted to see an example. Is that yours? I put one together. Okay, good. It uses CGLM. Hey. Cool. Oh, but it's huge. I just want the unit. Unit. Create graphics pipeline main. Yeah. SDL init. Okay, this is it. Edit all bin include live to path. Yeah, I'll see if what is more comfortable. Visual Studio 200G of pain, yeah. It's only pain when they degrade perf on purpose, like with loading code editor thing. Yeah. Visual Studio is a piece of architecture. Add include directories, and they added all of this. Okay, let's see. So we have all of this. I think I shouldn't use MGUI yet. Main, render, UI, all of this, no. Remove all of this. I wonder if I can do directly. Oh, that is so terrible. Yeah. I wonder if I can just do this. I think it should work. And this should be include. And then library should be live, I think. Wait. Yep. Yep. And then that and CGLM. All right. We do this glue, we don't need it. Why does it have a DLL? Error count is equal to 3. Yeah. Then glue 32, OpenGL 32. I'm not sure about this, and I'm not sure what I have to. Link here. We don't need this. Okay, so they added that. They add this to the include. Additional library directories. They add live and GLFW. Additional dependencies. And they added Vulkan 1. Okay, that was it. Vulkan 1 and GLFW. Now I'm not sure if I need all of this. Yeah, so Vulkan 1, I wonder if I have to, or are we gonna use directly Vulkan 1? Maybe I have to set 1.3, I'm not sure. First steps are worse than changing from forward to different, connecting MGUI REST isn't that bad. Remember that after this Vulkan tutorial I created it from scratch reading just docs to learn more. Pain is when you hit driver bugs, like I'm pretty sure I did with DX12 mesh shading on NV. Yeah, I mean finding any driver bug must be a pain. One is not a version. Oh. I thought it was. Thanks for the follow. I didn't get to see. Okay, anyways, anyone who followed, thank you. It's Ben Stub, hello. Hello from Twitch. Okay, so that is already there. C++ 14. Okay, and that's it. This might be useful though. So they install everything like this. Same with GLFW, same with GLM. I didn't know you could install GLM like that. Then shader compile. They set it up. And then they make a make file. Oh, they compile with. Oh, 2. Okay, we can do that. Vulkan. Why not Vulkan 1? Okay, well that should be it. Now we have to make it work in our machine. So, not this. No, not this either. Main. And render. UI, we don't need it. Yeah. UI, we don't have it. Render, it's what? Camera, we don't have camera. I removed it, yeah. And base.h. We won't have this. We won't have this. We won't have this. We won't have any of this. Okay, so they do SDL init video if it is equal to 0. Okay, I was doing this wrong. Oh, but it returns bool. Yeah, then what are they doing? Then SDL window Vulkan. Oh, because I can just pass in the window flags instead of doing it like this, I guess. Show window hidden. No. Show window resizable, yeah. Okay, that is the same. But they don't set the version of Vulkan, weirdly. Then window position. Set window relative mouse move, yes. Oh, we don't need that. And then they have init Vulkan. Show window, and that should be it. Init Vulkan. Okay, I think that's already something else. Init OpenGL. Yeah, not that. Init Vulkan. Also, this can just be static, yeah. Clear color, color. Oh, we don't have it anyways, so whatever. Set target FPS, whatever. Process UI event. That's from that. Mouse movement, we don't care. Input mode, we don't care. F5 scene update shaders, yeah, not yet. Handle input, we don't care, and actually I can just remove this for now. Clear screen, empty. Clear screen. Do not do resizable window just yet. I mean, I guess I have to allocate based on window size. Oh, no, because I have to change the viewport by callback or whatever. Since it will crash if you resize. I see. So init Vulkan. Yep. Begin drawing. What's this? Limit render UI, not yet. SDL swap window. What are we doing here? Poll events. Okay, so they're not swapping window yet. Just gonna comment it out. GL. What's this? Render GL context. We don't have that. Yeah. Go to main again. Just that today I'm on Twitch. Hey, YouTube chat. Hey, sorry, I didn't read you anyway. I don't know if you're still there. No sub, clear are gonna be the render pass. Okay. So the init should be pretty simple, like that should be it. And it has glue, which we don't need. Okay. And then from vendor, I already took away glue, CMGUI, I'll remove it for now. And that should be it. Build, I'm gonna remove it to cache as well. Git ignore whatever we're ignoring. Yeah. I should probably remove what I have already in here. Okay. I mean, I know I'm gonna get an error, but okay, so C, MGUI, SDL, of course. Where is it? Here. Okay, handle input on render.c. By the way, before we install, just create the compile commands, please. There you go. This worked. Okay. Damn. LSP restart. Okay. What happened to my ASP? Okay, there we go. Well, I don't know where it's failing. Undefined 104. Handle input Oh, because it's below, no? Yeah. And I removed it from here. Handle input. I do have it in here. Okay, that's weird. Are you unemployed? Yes, I am. Why are you asking? It's by choice, though. We don't need to clear screen and... Okay, I'm a bit confused. Why is handle input not working? Maybe I didn't save. Can happen. UI, let's just remove that. Let's just remove everything. Yeah, it's not finding it for some reason. Oh. No, I don't have it. Okay, I'm not sure what happened. Handle, wait, yeah, okay. Okay, black screen. That should be good, no? Because if I don't init with Vulkan, what happens? Let's just say I just give 0 here, and this is also commented. Okay, it also gives a black window, so I'm not sure if it's good. But I'll assume it's good. Choice of being unemployed. Yeah. It came to my mind since I'm technically supposed to be in the clock right now. Oh. Why not blue screen? Yeah. I mean, I can understand that. I'm just unsure why does it render if I don't set that I'm using Vulkan. Right. So a little weird. Because like if I just set everything here to 0 and I don't tell that I'm using Vulkan, it shouldn't work. But it's also working, so yeah, I'm not sure. It will use OpenGL by default, do you think? Could be. Zero is... So you have OpenGL here. Maybe it's default. Let's give it a random number. Okay, there we go. No. Well, sorta. I'm not sure. I'm not sure. You know, let's assume that it is working. Too many windows. I need a window manager. SDL external, I think, but uses none, but it won't work. It will use none. Oh. I mean, they initialize it like this on here. Window hidden, window resizable. And then I have set window relative mouse mode. Oh, okay, whatever. They do GLFW API here anyways, so I'm not sure. Well, after all of that, what? They showed a black window as well. Oh, where is it? Yeah, here. Well, it was a white one. 12 extensions supported. Where is that from even? Extension count. Oh, right. Let's try to do something like that. Printf. And I have to import this. I'm guessing, where are they importing it from? Well, yeah, right, I shouldn't have to, right? Because I'm already include. Yeah. But maybe I need to do include Vulkan. I'm not getting any auto completion, so I'm not sure. Vulkan H could be. No. Oh, it does work. It's just that LSP is a bit dumb. Job of the future and we still unemployed. Yeah, our future self is working. Vulkan didn't load on stream chat. Okay. Log info, does this work better? Yeah. Oh god. Okay, well, that's it. The number of extensions shouldn't be 0. Congratulations, you're all set for playing with Vulkan. Good. Are you trying to write HTML on the Twitch chat, on the YouTube chat? Como Revi is good, unironically. What is that? I wonder. I'm searching it on the second screen because okay, I found some Japanese stuff. General structure, init Vulkan main loop cleanup and app run. We first include the Vulkan header from Lunar G SDK, which provides the functions, structures, and enumeration. The SD accept and IOStream headers are included for reporting and propagating errors. The CSTD live header provides the exit success, exit failures macros. The program itself is wrapped into a class where we'll store the Vulkan objects as private class members and add functions to integrate each of them, which will be called from init Vulkan function. Once everything has been prepared, we enter the main loop to start rendering frames. We'll fill the main loop function to include a loop that iterates until the window is closed in a moment. Once the window is closed and main loop returns, we'll make sure to deallocate the resources we have used in the cleanup function. If any kind of fatal error occurs during execution, then we'll throw a std runtime error exception with a descriptive message, which will propagate back to main function and be printed in the, okay, yeah, I mean, we can't do this, but we can just assert. An error that we will deal with soon is finding out that a certain required extension is not supported, okay? Every chapter that follows after this one will add one new function that will be called from init Vulkan, and one more new Vulkan object to private class members that need to be freed at the end in cleanup. Just like each chunk of memory allocated with malloc requires to free, every Vulkan object that we create needs to be explicitly destroyed when we no longer need it. In C++, it is possible to perform automatic resource management with RAII with smart pointers provided in the memory header. However, chosen to be explicit about allocations and the allocation of Vulkan objects in this tutorial. After all, Vulkan niche is to be explicit about every operation to avoid mistakes, whatever you say. So it's good to be explicit about the lifetime of objects to learn how the API works. After following the tutorial, we could implement automatic resource management by writing C++ or by providing custom deleter to either RI is the recommended model for larger Vulkan programs, but for learning purposes, it's always a good thing to know what's going on behind the scenes. Oh, a window manager. Is that the one that is written in Rust? I think I've seen it. Oh yeah, I know it. I could definitely try it out. I'm just hoping it's not bugging for Windows. I mean, it's been in development for how long? Since 2021. So maybe it's good. If this won't work, I stop it. Yeah, it doesn't work. I think you can try catch in C on window, funnily enough. Yeah, I mean, there is this try catch thing. I think it's a GNU extension. Didn't use any window manager on Windows. What is the window, the new theme that you're using? I'm using, I mentioned it the other day, it was Grubbox Material, maybe? Yeah. It's this one. Grubbox Material. Vulkan objects are either created directly with functions like bkcreate or allocated through another object with functions like bkallocate. After making sure that an object is no longer used anywhere, you need to destroy it with the counterparts bkdestroy and bkfree. The parameters for these functions generally vary for different types of objects, but there is one parameter that they all share, pallocator. Is an optional parameter that allows you to specify callbacks for a custom memory allocator. We'll ignore this parameter in the tutorial and always pass null pointer as an argument. Integrating GLFW. GLFW includes Vulkan. Works perfectly fine without creating a window if you want to use it for off-screen rendering, but it's a lot more exciting to actually show something. First replace D with this. That way GLFW will include its own definitions and automatically load the Vulkan header with it. Add an init window function and add call to it from the run function before the other calls. We'll use that function to initialize GLFW and create a window. They do this. Does it change anything? Actually, no. Yeah, so I'm not sure what it is for. Are they including anything here that I don't see? Include. Yeah, this. Same thing. And that's it. I need to take off my hoodie. Will you try to do some cool compute shaders later? Not sure. I came across some of your videos. The intuition behind them is brilliant, and I can't wait to see where you end up. I'm excited too. I mean, the channel is doing pretty well. And thanks for the message. Vulkan.h, keep both for surface, creating surface, and working with window won't work without it. You need both Vulkan H and SDL Vulkan. Okay. I'm guessing I need this here. And I can just have that here too. Okay. The bare first call in init window should be GLFW init, which initializes blah blah blah. Yeah, skip all of that. GLF pull events, and then clean up. We don't have cleanup. Destroy, render quit. Render quit. When you run the program, now you should see a window titled Vulkan show up until the application is terminated by closing the window. Now that we have the skeleton for Vulkan application, let's create the first Vulkan object. Creating an instance. The very first thing you need to do is to initialize the Vulkan library by creating an instance. The instance is the connection between your application and the Vulkan library. And creating it involves specifying some details about your application to the driver. Start by adding create instance function and invoking it in the init Vulkan function. Sure. Init Vulkan. Init. Sorry. Create instance. Oh god, my A key is not working. Additionally, add a data member to hold the handle of the instance. Alright. Let's add a member to our global state. I'll keep it like this for now. Now, to create an instance, we'll first have to fill an struct with some information about our application. This data is technically optional, but it may provide some useful information to the driver in order to optimize our specific application because it uses well-known graphics engines with certain special behavior. The struct is called bk application info. Yoink. Yoink. Now this is info, not instance. Okay. Hello triangle. Hello Vulkan. Version 1. Oh, here's where you specify the engine, the version. Engine name, no engine. Okay. I see. There will be a lot of them. Here you specify the version of Vulkan. Yep, I see. Any specific reason why you're using C for all of this? No, not really. I like C. If you would be sane, you would probably use C++. But I don't mind the overhead that using C adds. Well, it's not overhead, it's verbosity. Yeah, like pain. As mentioned before, many structs in Vulkan require you to explicitly specify the version in the my dyslexia is getting a bit crazy. As mentioned before, many structs in Vulkan require you to explicitly specify the type of the S-type member. This is also one of the many structs with a pnext member that can point to to extension information in the future. We're gonna oh god. We are using value initialization here to leave it as no pointer. A lot of information in Vulkan is passed through structs instead of function parameters, and we'll have to fill in one more struct to provide sufficient information for creating an instance. This next struct is not optional and tells the Vulkan driver which global extension and validation layers we want to use. Global here means that they apply to the entire program and not specific device, which will become clear in the next few chapters. I need to stop the music because it's hurting my head. Stroke, yeah. Got Vulkan 1.0. Has this tutorial not been updated in the last 10 years? Maybe it has been updated and they didn't update the version. Kind of like the OpenGL tutorial where they use 3.2, I think. A lot of information in Vulkan is passed through structs instead of function parameters, and we'll have to fill in one more struct to provide sufficient information for creating an instance. This next struct is not optional. Yeah, we already read that. Okay. So again, I'm gonna init to 0. They said they were using no pointer for whatever. I'll just use it like that. The first two parameters are straightforward. The next two layers specify the desired global extensions. As mentioned in the overview chapter, Vulkan is a platform-agnostic API, which means that you need an extension to interface with the Windows system. GLFW has a handy built-in function that returns the extensions. It needs to do that which can... Damn, I'm tired or something. My dyslexia is getting very bad. I actually have this dyslexia, guys, just so you know. And don't judge my reading. It needs to do that which we can pass to the struct. So it has the count. GLFW will get required instance extensions. You pass the count. And that. Okay, and I'm guessing init Vulkan, what was it? Yeah, here it is. So they're doing the same, create info as type whatever, get required extensions. Is that from, okay, we're gonna ignore that. Ignore that too. SDL create surface. That's it. Okay, I'm just gonna copy this and keep it as reference. Do you mean inheritance? Aren't those cool trucks supposed to be enough? Yeah, I'm not sure. I mean, I have to pass them to SDL. Get required instance extensions. Instance or extensions. Get required extensions. Ah, he gets it from here. Look at that. So it would be const char pointer SDL extensions and U32 SDL extension count. I wonder why it is a pointer. Because yeah, whatever. If validation layers are enabled, we need to request the extension as well as the extensions required by GLFW. What do you mean? Also, okay, never mind. Vulkan get instance extensions, yeah, enable validation layers. If validation layers are enabled, add the debug utils extension. Are they doing that? BK debug utils. Debug. No, they do it on the next chapter, it seems. So I'll just yeah. Oh, okay. So they copy that. Oh, so we're not returning count, no? Oh yeah, we are updating it, I guess. Let's just return SDL extensions for now, directly. Render quit 1 log error. I like how they made the example, but they are adding GLFW here. Have you tried the new GPU stuff from SDL3? No, I've seen it, but I haven't tried it. Okay, I guess that should be it. And then they do this. Okay. SDL extension count, SDL extension name. Well, SDL extensions. I should probably log both of these. This is it. But I can't. Oh, right, because it's let's just do the first one and see. Yeah, actually after that let's abort and make sure all of this works. Maybe. Yeah, SDL extension count 2, PK KHR surface, makes sense. It's BK surface KHR, I think, yeah. You know your stuff. Let's see if it is. Win32 surface, yep, indeed. Okay. The last two members of the struct determine the global validation layers to enable. We'll talk about this more in depth in the next chapter, so just leave them empty for now. Alright. We don't need this anymore. I'll just keep the count for debugging purposes. Needs to create an instance and we can finally issue the bk create instance call. Okay, so we added that too. These validation layers, and we can just create a result which we can just return. Well, what are we doing with result? Oh, because bk result was, yeah, an error. Okay. You'll see the general pattern that object creation function parameters in Vulkan follow is pointer to struct with creation info. Yeah. Pointer to custom allocator callbacks, which we don't have. Pointer to the variable that stores the handle to the new object. Okay. If everything went well, then the handle to the instance was stored in bk instance class member. Nearly all Vulkan functions return a value to bk result that is either bk success or an error code. So we can just assert result is equal to bk success, they said. Yeah. Init Vulkan failed create instance returned error, and then whatever. Okay. Now run the program to make sure the instance is created successfully. Oh, isn't bk success? What? Yeah. Okay, there we go. My bad. Oh, you can do that? String underscore bk result. What? I got baited. You need to include it. Right. String underscore, that's a weird naming convention. No code actions. I'll probably have to... Where is it? This. Yeah. Okay. So after that, if you're using macOS, nope. But what do they do? Okay. Checking for extension support. If you look at bk create instance documentation, then you'll see that one of the possible error codes is extension not present. We could simply specify the extension we require and terminate if that error code comes back. That makes sense for essential extensions like Windows System Interface, but what if we want to check for optional functionality? To retrieve a list of supported extensions before creating an instance, there's the... yeah. It takes a pointer to a variable that stores the number of extensions and an array of bk extension properties to store details of the extensions. It also takes an optional first parameter that allows us to filter extensions by a specific validation layer, which we'll ignore for now. To allocate an array to hold the extension details, we first need to know how many there are. You can request just the numbers of extensions by leaving the latter parameter empty. So you do that and you get it on the extension count. Now allocate an array to hold the extension details, like so, given it count. Contains the name and version of extension. We can list them with a simple for loop. You can add this code to the create instance function if you would like to provide some details about the Vulkan support. As a challenge, try to create a function that checks if all the extensions returned by are included in the supported extension list. Sure. This needs to be before check validity of extensions. Then they create a vector. Interesting. I mean, oh, right. Let's just okay. And it just passes in data. No pointer, no extensions. Dot data, yeah, pretty much. So we can do we have vector? Not anything. Vector. What do we have? Backtype. Vector types. Oops. Backtype, and it was bk something. Where is it? This. Vector bk whatever, and then that. Yeah. Wait, I had a function for vector init, vector create. I swear I did. Vector reserve, okay. But it's the same thing. Wait, never mind, it's not. Yeah, vector reserve. Serve. Extensions. Extension count. What? Why is it not working? Vector back reserve, my bad. Okay, and after that it just does this. Oops. For const auto, do I have back for each extensions and extension log info extension name. Okay, and that should work perfectly. Available extensions, and it didn't do anything. Extensions.length. Zero. Wait, what? Available extension 0, extension length 0, extension supported. Where is that extension supported? Oh, that is on here, right? I don't need that. Well, I guess log info. Maybe I have a bug on that function. Extension count 19, yeah. So that is working. And then when I reserve, I do the capacity. right? And then I malloc based on count. Looks correct. Also, I'm wondering, why do I have to give it as a pointer here? And do I have to give a pointer to this? No. Capacity, not size. Yeah, it's called capacity. Maybe I have to update the length. Right, because every time that it's pushing, it's doing it on here. So I would probably have to update the capacity as well, the length as well. So extensions dot length is equal to extension count. Yeah, that should be it. There we go. So if, and we can just assert that each of the extension, right, but it's not in order, right? Because we have this, we have this. But it's not in the same order. Is right now, wait, what? Hey, is right now learning OpenGL? Should I complete learning OpenGL and then go to Vulkan? Or shall I directly go to Vulkan? What's your opinion? No, just finish. I mean, if you're about to finish it, then just finish it. Programmers are known for not finishing their projects, so try to set a goal and get until there and then move on to Vulkan. SDL extension count, yeah. Okay, so then we for SDL extension count and I++. Then char pointer, I think constant char pointer, current extension, and then SDL extensions I if, and then we can just back for each here. We should for loop as well. Wait, for size t join extensions dot length I plus plus j plus plus. If current extension is equal to extensions dot data j, I need to use stir compare. Okay, what is that? Oh, what is it? Right, maybe extension name. Then we just log it and break. just I32 available is equal to 0, available is equal to 1. This is so bad. And then extension, current extension is available. If available is equal to 0, I can just, that's not equal 0. Available can just be bool. Extension S is not available. There you go. Good. So instead of doing this, we can do this, and then we can do extension count. Wait. XDL extension count 2, available extension count 19, and we just print each of them. Okay, well that's it. I don't like that. Yeah. Okay, anyways. Cleaning up. BK destroy instance, okay. If render BK, what is render? Oh. Instance, it's not equal no. Render that instance, no. There we go. We don't need to swap, supposedly, and yeah, that's it for now. The parameters for BK destroy instance functions are straightforward. I'm guessing it's the same thing, like the allocator or the custom allocator, whatever. Yeah, allocation callback. The allocation functions of Vulkan have an optional allocator callback, blah blah blah. Will creating the following chapter should be cleaned up before the instance is destroyed. Yeah. Before continuing with the more complex steps after instance creation, it's time to evaluate our debugging options by checking out validation layers. Shouldn't it be stir compare or... Oh, you're right. You're right, actually. It was... I hate that convention, by the way. Like, this is so bad. This is why I have my own string functions and I don't use the functions from the standard library. By the way, I wonder how many seg faults you will get later. I don't know. I don't know how hard it's gonna be to manage memory. Depending on that, it can be a lot or not much. Okay, well, what are validation layers? I need some water, and I need to pee. Yeah, no intermediate strings weren't the greatest idea, but hey, it was 70s, yeah. I mean, they did a great job on C, honestly, for it being like such a revolutionary idea. I don't know what there was before C, so maybe they got inspired on Pascal or whatever there was before that. But they did great. But strings are still a pain. Be right back. Okay, I'm back after the bathroom break. BEC with many missing features. Yeah, I saw the BEC mode. It wasn't great. Okay. What are validation layers? The Vulkan API is designed around the idea of minimal driver overhead, and one of the manifestations of the goal is there is that there is very limited error checking in the API by default. Even mistakes as simple as setting enumerations to incorrect values or passing null pointers to required parameters are generally not explicitly handled and will simply result in crashes or undefined behavior, which is good because it means that it does less checks, but it's also bad because you don't have error checking by default. Because Vulkan requires you to be very explicit about everything you're doing, it's easy to make many small mistakes like using a new GPU feature and forgetting to request it at a logical device creation time. However, that doesn't mean that these checks can't be added to the API. Vulkan introduces an elegant system for this known as validation layers. Validation layers are optional components that hook up into Vulkan function calls to apply additional operations. Common operations are checking the values of parameters against the specification to detect misuse, tracking creation and destruction of objects to find resource leaks, checking thread safety by tracking the threads that calls originate from, logging every call and its parameter. This is cool, by the way. Logging every call and its parameters to the standard output, tracing Vulkan calls for profiling and replaying. Here's an example of what the implementation of a Vulkan of a function in a diagnostics validation layer looks like. So you have create instance, you make sure that these are not null pointer, and then you actually create it. Makes sense? These validation layers can be freely stacked to include all debugging functionality that you're interested in. You can simply enable validation layers for debug builds and completely disable them for release builds, which gives you the best of both worlds. Vulkan does not come with any validation layers built in, but LunarG Vulkan SDK provides a nice set of layers that check for common errors. They're also completely open source, so you can check which kind of mistakes they check for and contribute. Using validation layers is the best way to avoid your application breaking on different drivers by accidentally relying on undefined behavior. Validation layers can only be used if they have been installed onto the system. For example, LunarG validation layers are only available on PCs with the Vulkan SDK installed. There were formerly two different types of validation layers in Vulkan, instance and device specific. The idea was that instance layers would only check calls related to global Vulkan objects like instances, and device-specific layers would only check calls related to the specific GPU. Device-specific layers have now been deprecated, which means that instance validation layers apply to all Vulkan calls, thank God. The specification document still recommends that you enable validation layers at device level as well for compatibility, which is required by some implementations. We'll simply specify same layers as instance as at the logical device level, which we'll see later on. Using validation layers. In this section, we'll see how to enable standard diagnosis layers provided by the Vulkan SDK. Just like extensions, validation layers need to be enabled by specifying their name. All the useful standard validation is bundled into a layer included in the SDK known as BK layer Chronos validation. Let's first add two configurable variables to the program to specify the layers to enable and whether to enable them or not. I've chosen to base that value on whether the program is completely compiled on debug mode or not. The nDebug macro is part of the C++ standard and means not debug. Makes sense? I'll just keep it as a We can keep it like this. And then validation layers, this. Do we really need to create a vector for that? We'll add a new function, check validation layer support, that checks if all of the requested layers are available. First, list all of the available layers using the bk enumerate instance layer properties function. Its usage is identical to bk enumerate, and yeah. Okay, so you give the count, your count, and then you create a vector, give it the data. No, then here we need to do bk layer properties. And then we do vector bk layer properties, which we init to 0, and then back reserve available layers, layer count. Wait, what? There you go. Then why does it return false? What you doing? Vulkan. Vulkan shenanigans. Next, check if all the layers and validation layers exist. Which, well, look, they do pretty much the same. Oh wait, this is the same code I have. Look at it. I mean, they use for each or whatever it is. And they have false, check the layer name and whatever, and if not, then return false. I just assert it. Okay, I like it. Size ti is equal to 0. I is less than layer count, I plus plus, and then available layers. I think I'll just create an array. Yeah. Size j I0, I is less than, what do they name it? Layer properties, validation layers, right? Validation layers count. We can do extern, what would it be? Char pointer, validation layers. Yeah, validation layers and validation layer count, layers count, size 2. And we just define both of these in here. I could add it to render, but yeah, I'll just add it to render. I don't know why would I do this. So instead of, yeah, here I guess. And here would be render and an array. Oh, this does not work. Okay, whatever. I'll just make it a validation layers, whatever it is. Oh, it can just be a vector string. Vector string? Vec string. I'm sure I create something like that. Vector, vec type, string vector. Yeah. String vector. Validation layers. Alright. And then validation layers can just be back push. What was it? You. It takes in, okay, good. I'm gonna check that later, but for now, I gotta go, okay. See you, Toza, thanks for the help. You've been learning since you started, because you didn't finish the setup yet. Is it hard, or it's just new paradigm? Yeah, since I started, I've been creating device, whatever, this is just setup. It's not hard, it's just a lot more verbose, right? It's like 1,000 lines for initialization or whatever it is. Validation layer length. And then available layers or layer count. Layer name. Yeah, I guess that. And it would be current layer. Current layer, current available layer, available layers, J, data. And I just need layer name. And then current available layer, whatever, and then the same thing, current validation layer that is equal to render validation layers data I and data. Oh god. Current validation layer. And then if validation layer is found, we do that, or else we do that. And then we can just void pointer, just void. Here we don't do anything, and here we just assert the same way that we did before. Your thumbnail says graphics, by the way. Yeah, we're doing graphics. Well, not yet, but soon will be. Validation layer with that name, and then current validation layer. Yeah, and the last thing I'm missing is available layers dot length is equal to available layer count. Is that it? There's so much room for mistake with this. Not enjoying it. Oh, my bad. Yeah, didn't see the graphics. You dyslexic bitch. Fuck you. Right, but it must be way more capable, I suppose. Yep. Somewhat more capable. Hello, Radio Dwarf. Wait, Radio Dwarf. Don't I know that name? Never mind. I don't. Hi, what tutorial are you using? I'm using vulkantutorial.com. Okay. We should check validation layer before, no? Now, is this the right order? So I'm going through all the validation layers. In this case, we just have BK layer Chronos validation. Then we go through all of them. I check current validation layer. Do layer found is equal to false. Current validation layer from available layers data.layer name. Current available layer, current validation layer is equal to 0, then current found is equal to true, we break, and if this is false, we just assert it. Good. Check after the instance creation. Is it? Don't I have to add the validation layers here? Yeah. That's what I thought. I started using monospace fonts because of you. You mean the comic mono? Or just mono fonts? Because if it is comic mono, then I respect you, else no respect. Because you create instance depending on layers. Yeah. Alright, so they do that. And then when creating instance, they check this. We are asserting it directly. I don't even need this, honestly, right? I will just remove it. Then if enabled validation layers on create info. I need this too. Which is validation layer size. So render validation layers dot length, and then same thing but with data. So this is const char const const char const. Yeah. No, I hit comic. I'm using another one. Can't remember the name right now. Comic Sans is the best. Okay, so I'm not sure if I should add it here or here. Ah, look, I have enabled layer count 0, so that's not it. If the check was successful, then BK create instance should not ever return a BK error layer not present error, but you should run the program to make sure. Okay, so let's try that. Okay, good. So much code, I'm not even sure if I'm making any mistakes. They're all similar though, monospace ones. I mean, they're mono. The validation layers will print debug messages to the standard output by default, but you can also handle them ourselves by printing an explicit callback in our program. This will also allow you to decide which kind of messages you would like to see, because no necessary filters. If you don't want to do that right now, I want to. To set up a callback in the program to handle messages and associated details, we have to set up a debug messenger with a callback using bkexit debug utils extension. Well, first, wait. Okay. Get required extensions that will return the required list of extensions based on whether validation layers are enabled or not. They are by default, so you know. Also, this should be static. And this will be a string vector. What? Oh, this is what we already have. Wait, I'm stupid. So what does it do? GLF extension count. Yeah, this is what we had. Then it grabs the extensions. Oh, because it directly returns them from here this time. Okay. Then GLFW get required instance extensions. GLFW extension count. STD vector extensions. Okay, I see. And if so, then it pushes this. We can do that. We can do that, and I didn't like the way they did it here. Like they just mem copy. We can do better. Okay, instead of where's back reserve here? We should probably change the vector dot length is equal to count as well, because it makes no sense that I have to do this twice, right? Dot length. Dot length. Yeah, so it should do it as well in here, right? Monkey font. Have you used any C23 feature so far? No. It's just for the clickbait. Okay. And are we passing the count? No, we don't need it anymore, right? So we can just do nothing. SDL or extensions in general, right? And is equal to 0. Then we get the count, which we can just define here. SDL extensions count, yep. SDL extensions count, pass it like that. Do this. I hated that wait. I don't have to do that. Okay, never mind. SDL extensions is equal to null, then we can just assert it. And then just this. We need to add assertion on another place, so it quits the render. Back reserve extensions and extension SDL extension count. It should be right after this. Right after this, yeah. And then this, instead of being SDL extensions, it can be extensions.data is equal to that. Oh. Okay. We can create a char vector. Technically, most of C99 isn't C23. Yeah, I mean, I'm saying C23 doesn't make that much of a difference. You don't like monkey? What do you mean? Yeah, but C23 have few cool things like defining enum members, types, and const expr. Yep. I think the C23 also has the type function on macros, or whatever it does, and you don't have to use the GNU extension of type __, or that is from C11. I don't even remember. Vector char, and this can be just a char pointer. Okay, what is wrong? Why am I... char vector. Vector char. This naming convention that I created is so terrible. But I'll just keep it like that. Consistency.data. Extensions, oh my god. Yeah. So that, and then we need to push this, which is back push, extensions, and that. And then we just return extensions, which is vector char. There we go. Okay, I'm doing it wrong. Yeah, I mean, it doesn't work. You can't do it. Because he does 0, then passes GLFW extension count or whatever, and then creates another vector. Oh, it never creates the vector. Okay, I'm a dumbass. That was the problem all along. Yeah. SDL extensions. And then you can just... Alright. And then we have to make sure SDL extensions is not null, correct? Yeah. So we need to push this, and then we need to push all the other ones. For size t, I is equal to 0, I is less than SDL extension count, I plus plus, and then just... I mean, this is gonna be 2 every single time anyways. Extensions. We can go back to string vector. Let's keep it at vector char, just in case. Back push. Extensions, and current char pointer, I guess const. Current SDL extension is equal to SDL extensions I, and then just current SDL extension. And then at the end we push that. And then we should have at least 3. Extension count. Oh, this is EU. And we should actually go through each of them. I'm just gonna... And then this would be... Waste message being retracted. Are you guys deleting your own messages? Extensions at length. And this is current extension, and then we just log info. Current extension S, and then current extension. And I'm just gonna log this so I know when it starts. Yeah, and after all of that, what do we do? So we get char, vector char. We don't need this, we don't need that, we don't need that. SDL extensions length, and rather than SDL extensions, it just be extensions. Oh, I guess we have, okay. I guess required extensions. Required extensions. Yeah. Líder Nutria. I think I know that guy. Do you have experience with other graphics APIs? I did a bunch of OpenGL, but apart from that, nothing else. Well, I made my own pipeline, CPU render, whatever you want to call it. Uses SDL under the hood. Hello Freestyle, good day, good morning, how's it going? Extension required extensions dot length required extensions dot data. Oh god. Okay, where is that? Is that because of the OU error? Yeah, I think it is. That is on line 120. We can just do the same thing as I did on here. Okay, so we get extension count 5. What? Log info, SDL extension count, and then SDL extension count, ZU, D. Yeah, that's 2. So we push twice. Right? Then we get the extensions dot length. Oh, yeah, you see, this is where the problem merges again. We don't need to reserve anyways, right? Because it ends up with whatever amount, yeah. So then it's extensions 2, then extension count becomes 3 after we push that. And then we print BK KHR surface, BK KHR Win32 surface, and I'm missing one. Which is being printed, but we cannot access. Okay, how about it is a const char? Yeah. And we can just make this const. How about that? Okay. No, that's not it. So we create the extensions. We don't reserve because we don't need to. Then SDL extension count, which is what we should be doing, yeah. Let's name it differently. SDL, and same with this. SDL extensions. Then we go through each of the SDL extensions, we grab the current SDL extension and we add it. And then at the end, In extensions, we add this one. Oh, it's not allocated on the heap, maybe? That could be it. This is itself Vulkan macro. Oh, is that it? Is that the problem? You are correct, yeah. You are correct. Though that doesn't fix the problem of why I don't have it. Like, do I have to... That would make no sense. Because I don't need a pointer to it. Okay, it's weird. What if I push it at the start? Yeah. Then it breaks instantly. At least it's adding 3. I'm not sure why it's not adding the last one. I'm guessing it's because... I'm not sure, honestly. This is not const. Okay, how about if I do it like that? Utils extension. I do it like this, and then push it on here. And then I push this. Does it change anything? Like, something weird needs to be happening. What is value? Yeah, this, and it takes a pointer to it. That might be the problem. Yeah. Now the thing is, after I do this... Wait. Okay, whatever. Then we print current extension on here, and then we do available extension count. We do all of that. Then we create the instance, and it's breaking somewhere. But IDE I use Neovim, not an IDE. Maybe problem with no terminator. Alright, so we already fixed it, so that's not it. Can you check with debugger if array contains extension? It's so weird though that it isn't locked. So we already fixed that too. Now I think it's getting some seg fault or something. So this is seg fault number 1. Yeah. Okay. Well, I don't know how to debug it. It's definitely getting here, no? Got here. All good. Or is it not? I need to compile it again. Yeah, we get here. But then when we create the instance, that's when we face the problem. I think there is when it's breaking apart. Also, I don't know why it's not logging it. I guess I have to give the... give the callback. Though I'm thinking, okay, so then we have required extensions. This current extension, we can name it current required extension. How are you holding up? Okay, whatever. I'm holding up very well. I didn't yet lose my sanity, I think. Log info, current required extension. I mean, we are printing it already. Oh, what happened? I can't move. Okay, there we go. Current required extension. Yeah. So that is correct. We are making it const char const pointer. I'm guessing maybe this needs to be const. Can I add const here? No, it has no effect. Then this is const char, that is const char. Then here we're doing const char as well. So I guess we don't need to do that. Yeah, we don't. Still breaking, right? Is Vulkan easy for beginners? Definitely not. I don't recommend it. If you want to draw something on the screen, just go to OpenGL or Braille or whatever. Use a game engine. Then BK enumerate instance extension properties. Extension count, we get it from here. We go through all of the extensions. We check that current extension dot data at I is equal to the extension name. We set it to available, and that's it. Okay, something's going wrong on here. Or no, not really. Required extensions, we changed those two. Oh, they're using uint32. Could that be it? I mean, I don't think so, but... Let's try it out. Yeah. Okay, I'm gonna move this part. What is this? Check validity of extensions. Yeah, I can just name it like that. Static void check validity extensions. And we just add it here. And we need to pass in required extensions, right? Which is a vector char required extensions. Let's just pass in a pointer. If it works here, then it means that the data is good, I guess. Required extensions. Pointer. Yeah. Okay, it works. He breaks out of the inner loop, not outer. You have weird back push for validation name. Last time you changed it to an explicit variable, it helped. Yeah. So we said we are breaking right on here, no? I mean, after this, log info 1 and log info 2 should break here. Yeah. Then something I'm giving is not valid. Like something that I'm giving is a no pointer. It has to be one of these. Like if I set extension count to 0 and then we just comment that out, then it should work normally. It doesn't. Okay, so I guess it's this. Validation layers here. As you said, const char. Right, the other problem is validation layers is a string vector, so let's make it vector char. This is right at the bottom, so let's move all of this here. Same with this, I guess. Colors. Yeah. Vector char. Okay, good. And instead of that, const char validation string. It probably is this. Probably. Const char pointer. Yep. So I'm using data and somewhere. Where is it? Here. There we go. Thanks for the catch, MR Steuk, I don't know. German. Alexander Germak. Thank you, Alexander. Mr. Steak, okay. So I should definitely figure out the back push on here. So this is because it's passing in the pointer to this. For back push, whenever it is a string, I should do it differently, I guess. Yeah. Okay, whatever. Well, that works. Then we need to make this dynamic based on compilation target. Then we check the validity. Disable that. Good. Current extension, you can remove that. By the way, everything you pass to Vulkan gets owned by it, so you don't need to keep it. Okay. Thanks for that. I can then back free after each of the creations. For now, I'm just gonna let it leak, but afterwards back free each of the vectors, please. Thank you. Let it leak, let it leak. Oh god, man. Learning Vulkan? Yes, indeed. Okay, good. So we have that. Yeah. Now run the program to make sure you don't receive. Yes. We don't really need to check for the existence of this extension because it should be implied by the availability of validation layers. Now let's see what a debug callback function looks like. Add a new static member function called debug callback between the prototype. The BK API attribute and BK API call ensure that the function has the right signature for Vulkan to call it. Gotcha. I should probably create an entire different file for all of this, because it's starting to look a bit cluttered. So this is log info. Hello. Validation layer. And this. If you enable Vulkan 1.3 instead of 1.0, you could enable dynamic rendering extension, and then you won't have to create render passes and frame buffers. So let's work. Yeah, I mean, I'm up to doing that. Just not yet, since I want to learn the old ways. Does Vulkan API make you use the C++ standard, or you can use it with no STD? It's just plain C, but then you have Vulkan HPP, I think. Yeah, Vulkan HPP and others are separate from the main SDK efforts. Vulkan is painful indeed. You need to do 10 things to just set it up, and then another 10 things to draw a triangle, and then 10 other things to draw a rectangle. I mean, from what I saw from the steps for drawing a triangle, like, you do a lot of setup, like devices and whatever, then the pipeline, but then, like, that's it. If you want to use the same shader, if you want to use another shader, then you can just, do the same steps to create your object or whatever you want to call it, your pipeline. And then you use that pipeline to render that, and then you're done. Then I don't know how you pass BAOs or descriptors, whatever they have. That is probably more challenging, but this is not. Like, it's pretty simple. Just a lot more verbose. The first parameter specifies the severity of the message, which is one of the following flags: verbose, info, warning, error. So we can just switch through all of those. The values of this enumeration are set up in such a way that you can use a comparison operator to check if a message is equal or worse compared to some level of severity, for example, this. The message type parameter can have the following value: 7 has happened, unrelated to the specification or performance. Something has happened that violates the specification or indicates a possible mistake. Potential non-optimal use of Vulkan. They even tell you that? Cool. The p callback parameter refers to BK debug utils messenger callback data extension struct containing the details of the message itself, with the most important members being p message, p objects, and p count. Array of Vulkan objects handles related to the message and debug message as a no-terminated string. Finally, the p user data contains a pointer that was specified during the setup of the callback and allows you to pass your own data to it. Cool. The callback returns a boolean that indicates if the Vulkan call that triggered the validation layer message should be aborted. If the callback returns true, then the call is aborted with error. This is normally only used to test the validation layers themselves, so you should always return BK false. All that remains now is telling Vulkan about the callback function. Perhaps somewhat surprisingly, even the debug callback in Vulkan is managed with a handle that needs to be explicitly created and destroyed. Such a callback is part of the debug messenger, and you can have as many of them as you want. Add a class member for this handle right under instance. Debug messenger. Now the function set up debug messenger. Okay, create instance, we can add it here. And then right after that we just set it up. Debug messenger. Which depends on enabled validation layers. We'll need to fill in a structure with details about messenger and its callbacks. We won't have any data, so we also pass in a null pointer, okay, null, and it to 0. And we enable all of them, I guess. I'm sorry, I was not reading chat. Moves too fast. I had to make my own game framework a while back and got stuck at the rendering phase. Gotta push through. I got it stuck at uploading textures after fighting NVIDIA driver quirk. That was on DirectX now. I'm not sure if the tutorial got updated, but validation layers now complain about semaphores at frames in flight chapter, and I had to find the fix myself. But it's only after you draw your first triangle. Interesting. I had literally the same parallel I needed to create semaphore for everything, every single subchain image. Oh, I think they mentioned it. The message severity field allows you to specify all the types of severities you would like your callback to be called for. I've specified all types except for message severity info bit X. Here to receive notifications about possible problems while leaving out verbose general debugging info. Makes sense? Message type field lets you filter which types of messages your callback is notified about. I've simply enabled all types here You can always disable them, disable some if they are not useful to you. Okay. Finally, the field specifies the pointer to the callback function, which I am setting correctly, right? Yeah. You can optionally pass a pointer to, yeah. You could use this to pass a pointer to the Hello Triangle application class, for example. I will have global state, so I don't really care, for now at least. But it's a good setup to get started with for this tutorial. See the extension specification for more info about the possibilities. This struct should be passed to bk create debug utils messenger extension function to create the object. Unfortunately, because this function is an extension function, it is not automatically loaded. We have to look up its address ourselves using bk-get instant proc address. We're going to create our own proxy function that handles this in the background. About it right above the Hello Triangle application class definition. This is on create utils. Okay. bk create debug utils messenger extension. Then it returns func. Else extension not present. I see. I'll just add it on top of this. I guess I have to name it that. Yeah. Then we make sure it's not no. And then func, give it those. Why is it not? Okay. I'm not getting any syntax highlighting there. pdebug messenger, okay. So get instant proc address and it gives it the debug utils messenger extension. Will return null pointer if the function could be loaded. We can now call this function to create the extension object if it's available. Right. Which we do. Where do we do it? Here. And pass it all of that. So instance is render.instance create info null and debug messenger. What is that? This returns decay result. What is it? This. Right. And this is failed. Set up or could not find extension, I guess. Debug utils messenger extension. A string underscore, what was it? String underscore bk result, yeah, and then result. I'm unsure what is debugger debug messenger, oh, right, stupid. So it creates it with, where did I leave it at? Then it does this, then we create it. If it doesn't equal success, then we abort. Destroy debug messenger extension. Okay. I definitely need to create another file. And then we just if render, what was it? Debugger messenger. This is not a pointer though. Oh, it is a pointer. That's so bad. Do I need to pass render dot instance and what else? Oh, it's not defined here, right? I guess I should add it at the top of everything. And from what I remember, I need to, okay, first of all that, then what else? Debug messenger, and then PI allocator, which is null, and I remember I have to do this right before instance. Yeah. The XOF spec doesn't permit multiple set output calls for mesh shaders and directly says that it should be 0 by default, but I guess NVIDIA doesn't care and DirectX 12 encourages a different model to mine, or DX12 encourages. Well, it's a big problem that specification is not clear sometimes. Can't blame the driver manufacturers. So that's it. Yeah, so we destroy this before instance. Can we run this? Make sure it works. Okay. Where does it break? After, so definitely here, no? Nope. What? It doesn't get here? It does. Then why does it break afterwards? Yeah, it works. Okay, I guess I didn't save this. That was the problem. Yeah. Oh, I didn't save this. Right. Now if I set that up, it's all good, okay. debugging instance creation and destruction. Although we've now added debugging with validation layers to the program, we're not covering everything quite yet. The BK debug utils extension code requires a valid instance to have been created, and BK destroy debug utils messenger extension must be called before the instance is destroyed. This currently leaves us unable to debug any issue in the BK create instance and BK destroy instance calls. This part of the tutorial was kind of confusing for me because, yeah, I mean, I wonder what you would do with the types that they give you if you are doing it on Zig. Unable to debug any issues from create instance and destroy instance calls. So that's why it was not giving us any errors before, I guess. However, if you closely read the extension documentation, you'll see that there's a way to create a separate debug utils messenger specifically for those two function calls. It requires you to simply pass a pointer to a BK debug utils messenger create info extension struct to the pnext extension field in BK create info. First, extract population of the messenger create info into a separate function. Wait, what? Populate debug messenger create info. So we populated before with all of this. Then we created here, populated. And then you just use it on create instance. Right. And I should get that. Okay. So instead of this, I guess, we need this. What? This is 0, and of course why don't we give it no? I guess it's the same if we init to 0. Yeah. And then here we just do, oh, we can't do this, never mind. Wait, where did it go? Populate, yeah. Populate this, create info, pointer, and that's it. So this doesn't change at all. We just do this, then we assert it like we were doing here, and then when we are creating an instance on create info, yeah, here, if enabled validation layers, then we have the layer count, layer names, populate debug messenger create info. And this is on here. Wait, what? Debug, right on here. What? There we go. Pointer and pnext is that. enabled layer count. Okay, and what happens now? Good. Validation layer failed to open whatever. Epic Games, what? Okay, that's a bit verbose, but like why am I getting so many Overwolf OBS? To ensure that it is not destroyed before the BK create instance. Wait, what? Debug create info? Yeah. Is placed outside of the if statement to ensure, okay, well, we don't have an if statement, so it doesn't get destroyed. By creating an additional debug messenger this way, it will automatically be used during BK create instance and BK destroy instance and cleaned up after that. Testing. Now let's intentionally make a mistake to see the function layers in action. Temporarily remove the call to destroy debug utils messenger in the cleanup. Okay. Here it is. So that, and then we get all that obj error. Well, that's, we get better errors now, huh? Has not been destroyed. Yeah. This is object tracking. I guess I should disable all of this. By the way, thanks for the follow. I don't know who it was. I need to open Twitch. Twitch dashboard. Stream manager. Yeah. Vitali server. Hello. Thanks for the follow. Anyways, this works well, and it tells you even when you forgot to destroy an instance of something. So we forgot to destroy this, and it tells us. It's very detailed indeed. Yeah. Okay. If you want to see which call triggered the message, you can add a breakpoint to the message callback and look at the stack trace. Yeah, that's... I can even add that when executing with GDB. I can just like tell it which function I want to breakpoint in. That would be pretty useful. There are a lot of more settings for the behavior of validation layers than just the flags specified in the whatever. Browse the Vulkan SDK and go to the config directory. There you will find a bk layer settings.txt file that explains how to configure the layers. To configure layer settings for your own application, copy the file to the debug and release directories of your project and follow the instructions to set the desired behavior. However, for the remainder of this tutorial, I'll assume that you're using the default settings. Throughout this tutorial, I'll be making a couple of intentional mistakes to show you how helpful the validation layers are with catching them and to teach you how important it is to know exactly what you're doing with Vulkan. Now it's time to look at Vulkan devices in the system. How many graphics cards do I have? I have 2 now. Yeah. So I guess it's gonna mention both. I'm hoping. Anyways, we've been streaming for I think 3 hours, 4 hours. 3 hours 30. I'll stop the stream. Maybe I continue at evening or night. I'll eat and maybe come back to this off stream. I'm not sure. Probably on stream, but maybe I continue off stream. Anyways, see you guys. Bye bye. By the way, I didn't read your message, Vince. What do you say? I heard the word sick and sparked my attention. Yeah. No sick in this channel. It's prohibited. See you guys.